Hello, welcome back. In this segment, I will show answers to the following quiz questions. Consider the following fragment of assembly code and let's discuss the question. They want us to find the value of A and B. So we need to fill up something here and something here in such a way that the function returns 256. Okay. One possibility is that in that case, EDX must also have 256, right? Because the return value is stored in EAX. So in that case, B has to be a move. But let's see whether they have a move as part of the B answer. Yeah, they do have a B move. Okay. In that case, if we stick with move, we need 256 at EDX. But what is there in EDX? EDX gets a value from EBB minus 8, which means A must also be 256. But let's look at what are the possible answers for 256 for A. A doesn't have 256. A can have 255. The F is 255, and the rest seems to be not okay. So now we can think about other options. What if I take A to be FF, right? And in that case, EDX is 255, because as you can see here, I'm transferring 255 to EDX. Right, here is 255. I put it here, so this is 255 and EDX has 255. But then I have to do, I have one here in EBB minus 4. So possibly I can do an add as part of B. So let's look at B, whether we can select that answer. Yeah, we can select FF. FF is 255 over here, and then we select add here. Because EDX has 255, EAX already has 1, so answer is 256. So that's the answer. Okay, good. Let's move on to the next one. If X is a data type that can be represented using only 11 bits, okay, what are the possible values of Tmax, Tmin, Umax, Umin, and so on? Okay, let's solve that problem. Okay, so we have 11 bits, right? That means in terms of Tmax, Tmax means in 2's complement representation, what is the maximum value? The first bit must be 0. And the rest must all be 1. That is when we get the maximum. Okay, so what is the binary? This is the binary representation. We need to find the decimal representation in base 10. This is nothing but 2 power 0. This is nothing but 2 power 9. This is 2 power 10. Okay, so this is 2 power 10. And this weight is 2 power 9. And this weight is 2 power 0. Okay, so we are basically adding 2 power 0 all the way to 2 power 9, which is same as 2 power 10 minus 1, which is same as 2 power 10 is 1024, so it must be 1023. Tmax is 1023. Okay, in this place we have 1023. What about Tmin? Tmin, the pattern is 1 followed by all zeros, right? And this is negative weight, so this is minus 2 power 10, which is minus 2 power 10, which is minus 1024. So the answer here is 1024, in negative 1024 rather. Okay, so we don't even have to solve this. We know that Tmin is 1 more than Tmax and put a negative in the front. What about Umax? Umax means all or 1, which is same as, this is 2 power 0, this is 2 power 10, which is same as 2 power 11 minus 1. 2 power 11 is 2048. 2048 minus 1 is 2047. Okay, 2047. Okay, now Umin is simple. All of them have to be 0, which is 0. So that's it. All right, let's move on to the next one. So we need to download this binary and answer a couple of questions. Okay, so I'll show you how to do that. You click on this, it will open in your, we have to do it in virtual machine because we're going to analyze the binary. Okay, let me show that now very quickly. So I place the link here. And now I'm going to click download. So it's going to download to the download folders naturally. You can see save wherever you would like to save, but I'm going to save it in the default place, which is the downloads folder. If you don't know where it is downloaded, you can also check here. For example, open, you see here, open containing folder. So you can open it, which is under downloads. As you can see, it's under downloads. So all I have to do is look at my downloads folder. Right, and if you look at the downloads folder, I have my _bin, and now I can just load it into GDB and answer the questions they're asking. Let's look at the first question. The first question is How many bytes does the function hello require? Okay, let's look at it very quickly. Okay, so I'm going to answer how many bytes does the function hello require, and at line main plus 20, what is the value of EAX? So these two questions. That's easy. Disassemble hello. Yeah. So it starts here at 0 and it ends at 24. That means the 25 bytes. And the next question is regarding the main function. And they're asking what is the state of EAX at this point. Okay. Walk through it manually or just run it through, whatever you prefer. One is moved to EBB minus 4, and then B is added. That means B plus 1 is C. And the answer is C. Okay, C means 12. Okay, that's all. All right, let's go back to the share. So here, 25, and here it's 12. That's it. Okay. In the previous question at line, what type of data transfer is performed? Main plus 6. Main plus 6. Main plus 6 is basically immediate. This is immediate. You transfer it to memory. So immediate to memory is the transfer. Okay. So I would say immediate to memory. Yeah, here it is. Couldn't select that. Immediate to memory is the answer. Okay. Consider the following snippet of C code. Choose the best option that represents out of the printf function. So you have number 1 in X. Y is U int max. U int max means 1 all bit patterns. Okay, here is U int max. U int max is just 1 followed by 111. Let's assume integer is 32-bit. So we have 32 ones. And we are just doing a right shift by one position. That means this one will go away, which means we have 0 at the beginning, and then we have 111 all the way until 1. This is nothing but int max, right? Int max is the non-negative value for integers in 2's complement representation. Okay, that's it. And now we can move to the next one. Consider the following fragment of machine code. It's actually assembly code, but anyway, EBB minus 4 is having the value X. Choose the correct answers from the following options. Let's see. They said EBB minus 4 has value X. So that means EDX will have X here. So EDX will be X. And now the next line, we are moving EDX to EAX. That means EAX also has X. Okay. And next statement is we are doing shift left. That means we are multiplying EAX by 2 power 4. That's the meaning of shift left by 4. That means EAX will be 16X. Okay, and next statement is add EDX with EAX. What is in the EDX as X? Therefore, EAX as 17X. Okay, so this is 16X and this is 17X, right? So the answer, let's see what they're asking. Okay, so the original value of X is intact inside the memory throughout the execution. Yeah, we didn't change the X. EBB minus 4 is never updated. So that would be one answer. Okay, and the function returns 17X. So that's all. Okay, let's move on to the next one. Oops. Let's move on to the next one. Consider the following C code fragment. What would be the value of variable magic? Okay. X is short max, Y is short min. We are casting short max to unsigned sort, which means you have 0 followed by 15 ones, right? And X is, oh, one moment. Let me clarify that. X is short max, that's correct. And Y is short min. What is short min? 0 followed by well, it's short min in terms of negative is 1 followed by 0, 0, 0. Okay. All right, let's move on to the next question. X is short max, Y is short min. So it will be helpful to remember what is short max and short min. Short max is basically 0 followed by 1, 1, 1, 15 times. Okay. Short min is 1 followed by 15 zeros. Okay. So what is the question doing here? They take the X, okay, and they compare against Y. So Y is converted into unsigned sort type. Okay. It means the bit pattern doesn't change, of course, it's still the same. X becomes from 2's complement to unsigned, because whenever you compare unsigned with the 2's complement, you will automatically convert that into unsigned. So your short max is 0, 1, 1, 1. Okay, of course 0, 1, 1, 1 is smaller than 1, 0, 0, 0. Therefore the answer is 0. So the answer is 0 for this problem. The answer is 0. Consider the following assembly fragment of an unknown C function. The corresponding C function may have 2 integer type local variables. The final value of EAX is 0, 1, 4. Let's figure out what's going on. So local variables are referred using EBV -4, -8, and so on for integer types. So in that case, how do we figure out that? How many local variables? So from the fragment, we can make a guess. Here we are doing EBV -8. That means this is possibly one integer type. And here is EBV -4. That's possibly another integer type. So it makes sense to say there may be 2 integer type local variables. Okay. What about the final value of EAX? Let's see. EAX gets its value from EBV -4, which gets the value from EAX, which gets its value from EBV -8, which gets its value from this add. Okay, and 8 minus EBB is initialized to 0, therefore the answer is 1. Okay, so the final value of EAX is 1. I believe that's all.